Hello everyone and welcome to my channel Hypermesh Basic to Advanced. So to have a bit of a background about my channel, in this channel I make videos related to FEA and Hypermesh. So if you are interested in these topics, consider subscribing to this channel. And if you are already a viewer but not yet subscribed, kindly consider subscribing as this motivates me to make more videos. Okay? Okay, so moving on to today's topic. So in this tutorial, we are going to discuss about static analysis for the barrel of a gun. Okay, so this is going to be the first video in the part of the series of system analysis. Okay, in which we are going to analyze systems for different factors, for evaluating different factors, different loads. Okay, okay. So the barrel which I have taken here is the barrel of Desert Eagle. So if you know, Desert Eagle is a very popular firearm among gun enthusiasts. Okay. So what I have taken here is what I have meshed here is the section of the Desert Eagle barrel. Okay. And I have not the full barrel. So if you want to see how the full barrel looks, you can just see it here. Okay. So this is how the full barrel looks. Okay. This is the full barrel of Desert Eagle. Okay. And if you want to know how Desert Eagle looks, I have posted that image in my website. I have provided an exploded view of the gun with its components, so you can check it out there. Okay, okay, fine. So as you can see, I have taken the section view of the barrel and I have meshed only the section for this analysis. Okay, so what we are going to do in this analysis is we are going to put a pressure load on the inner wall of this barrel area, okay, inner surface of this barrel area, and check how it deforms or how it behaves under this pressure load. So how is this pressure load generated? So while firing of the bullet, if you know, in firearms, what happens when bullet is fired, it travels to the barrel, okay, and the exhaust gases also follow. So the gases which follow through the barrel, it's the pressure due to those gases. Okay, fine. So I have already meshed the model. So I have taken the section view as I told before, and I have meshed the model using tetra elements. You can see here. Okay, I've meshed the model using tetra elements. Yeah, if you can see, I have meshed the model using tetra elements. Okay, and yeah, so after meshing the model, if you have followed my previous videos, so you know what we do usually. The following steps: after meshing the model, we need to define the material and the properties. Okay, so the material here I have used is stainless steel. So the actual material used for the handgun might be different. It might be a different grade of steel. There might be a different standard. Okay, so this video, to give a disclaimer, uh, it's only for educational purposes, and this is in no way the exact values or exact material or exact properties used for the development or the production or the manufacturing of the firearm. Okay, so this video is just for educational purpose. Okay, of what goes into, just what is the thought process behind analyzing and designing a firearm. Okay, so here the material which I've used is stainless steel. Okay, so the EG new values and the density values are as follows, if you can see here. Okay, so I have defined the material. Fine. Next we need to define the property. So property, I have defined the solid property, P solid. Okay, the shell property I have defined just in case. This, just ignore this. Okay, so what I have used is solid property. Okay, and then we need to reference the solid property and the material under the component. Okay, fine. Next, what is next? We have meshed the model. We have defined the material and the properties. So next, what we have to do? We have to define the boundary condition. So what are the boundary conditions? So the boundary conditions will be the load applied on the inner face, the pressure load on the inner face of the barrel, correct? And then the SPC. Okay. So I have applied a load of 225 MPa, as you can see here on the inner face of the barrel. Fine. You can see here 225 MPa on the inner face of the barrel. Okay, throughout the length. So the barrel length is from this edge to this edge, correct? And this side is not the barrel. It's basically chamber, which used for chambering the round. The round just comes in here, and it is the primer gets exhaust. It gets blasted here, and then it travels. The barrel length is still here only. Okay. So I've applied the pressure of 225 here. Okay. So this pressure of 225, how did I arrive? Because I got this value from internet. Okay, and this is not the actual value which might be used again for the designing of the firearm. Okay, and the actual value might be much higher than that. Okay, but one thing to note here is the actual value available in the internet, the value available in the internet for the pressure generated inside the barrel during the firing of the bullet for this gun is higher, but I've taken it to be lesser because this is a, gas operated firearm. Okay, so basically, what is a gas operated firearm is the gases generated, exhaust gases generated while combustion of the bullet pyro. It's piped, it's channeled through this groove. If you can see here, this is the pipe. Okay, so it goes through here. Okay, and then it goes and then it actuates the slide. Okay, and that is how the shell is ejected and a new cartridge is loaded. So basically this is a gas operated firearm, so I'm assuming so there's a loss of pressure due to the circulation of gas through this line. Okay, so I have taken a lesser value as compared to what is given in the internet. Fine. Okay, so I have put a pressure load of 225, as you can see on the inner face of this. Okay, now we need to define the constraints. So if you can see, I have defined the constraints on the bottom face of this barrel. Okay, barrel structure to be precise. Okay, so why this bottom face? Because this is the face which goes and sits on the frame of the gun. Okay, so all this will get clear if you just check out my website. I have given the full picture of the gun there, and you can just see how this sits on the frame of the gun. So this is where the frame holds this in place and not the other parts of the barrel. So these parts needs to be constrained. I've constrained this part where it sits on the frame. Fine. Okay. So after this, so we have meshed the component. We have defined the material and the properties. We have defined the load collector. That is the boundary condition. Okay. So next, what we need to do is we need to define the load step. Okay. So I've already defined the load step, as you can see here. Okay. So I'll just expand this, and yeah. So if you can see, I have selected the analysis type as linear static, uh, and the SPC. I have referenced the SPC under the SPC field and the static load under the load field. Okay, static load is the pressure load that we have defined here. Okay, fine. So we have defined everything now. Basically, the meshed model, the material, the properties, the boundary conditions, and the load step. Okay. So we are going to run this in the Nastran solver. So for that, we need to do some extra steps. Okay. So what are the extra steps going to be? So we need to define output card since we are going to export this solver deck. Okay. So what are the output cards? What are the control cards? So for defining the control cards, first I'll just tell you that. We can go to analysis here. If you can see geometry 1D, 2D, 3D analysis, then we can go to control cards. If you can see here, okay, then we can go to solution. So here we need to define what solution we need. So we'll be using solution 101, that is statics. Okay, similar way we need to define parameters. Okay, so I have viewed auto SPC as 1, bailout as -1. This is not necessary. This is just used in case if you want to skip some bad elements, or uh, like some hindrance while evaluating hindrance. This basically eliminates the hindrance which is created by bad element quality or bad structures. Okay, so this is not necessary to use, but I have used just in case. Okay, then parameter post we have used as 1, weight to mass 0.001. Okay, next we need to define the output request. What all output requests we need to, what all output we need, correct? So I will need displacement, strain and stress for this case, since this is only static. This is not thermal or anything, so it will be only these three. Fine. Okay, so basically mesh model is defined, material and properties are defined, load collector and load step is defined, and control cards are also defined. So we are basically ready to run the model. Okay, so to run the model again, we need to go to export. If you can see here, this red arrow here, you can just click on there, and then we have this here. We can select the file type as Nastran, template standard format, select the file location, give it a name, and we can export it in PDF file, and we can just click on export here and it will export. I've already exported it. I'm not going to export it again. Okay, so next we are just going to open the Nastran solver and select this PDF file. Okay, okay. So once you have exported the PDF file and selected the file under the Nastran solver for the run will be complete, and then you can just select the PDF file and OP2 file here, and you can load the results as you can see on my screen. Okay, fine. So if you can see on my screen, so currently I have the displacement plot in place. So if you can see here, so the blue part, which is near the constraint part, has the least displacement, and the part at the center has the most displacement. Okay, so if you can see, the maximum displacement observed here is 20 mm. So 20 mm is a lot. Okay, and again I would like to put it that this is in no way the actual displacement or actual results which are obtained during the design. Okay, design of the firearm. Okay, this is just for educational purposes. Okay, and one more thing, the pressure load which I have applied, uh, okay, that I've applied uniformly on the throughout the barrel. Okay, which might not be the case during the firing of the firearm. Okay, so that also will be different. Okay, so this is a displacement plot. Okay, so next we'll see just the stress plot. If you can see a stress, we'll just click on apply and we'll wait for it to change, and yes, it changed. Okay, so we can see the stress plot here. So maximum stress observed is 6.32 into 10 to the power 4. Okay, so we'll just filter, if we can filter. Yeah, so the maximum stress is observed. Okay. Hmm. So if you can see here, the maximum stresses are observed around these regions. Okay, you can see here. Okay. Hmm. So all these areas, the maximum stresses, the stresses more than 31599 is what is observed, is what is shown here. Okay, fine. Okay. Okay, next we'll see the strain. So we'll observe the strain value here. Okay, so we'll again see where the maximum strain is observed. Hmm. Okay, so it's very little. Okay, and it's mostly around the sharp edges. If you can see here, somewhere here. Okay, okay. So basically, this is how we will perform a static pressure analysis on the gun barrel. Okay. So to summarize it, what we have done is to simulate the pressure load generated inside the barrel of a gun. Okay. Specifically, Desert Eagle barrel, which we have used in this tutorial. So to simulate that pressure load, we have taken the section of the barrel and then we have applied a pressure load of 225 MPa, okay, which in no way is the actual value used for the design of the firearm. This is just for educational purposes, okay. So, and we have simulated it and then we have got the results, which you can see are displayed on the screen, okay, fine. Okay, so this will be all for this tutorial. So I'll in the next tutorial I'll come up with a different analysis for different gun parts of Desert Eagle. Okay, so stay tuned for this series. I hope you will gain a better understanding of how we design products, how we design systems, and how we analyze these products and systems in the design phase. Okay, and what is the thought process that goes behind when designing these things. Okay. Uh, so this is all for this video. And before going, I would like to inform you people, as I've told in my previous videos also, apart from this uh, YouTube channel, Hypermesh Basic to Advanced, and my website, hypermeshbasic to advanced.in, I also have a finance website, 10%finance.com. The link to which I will give in the description. So you all can check it out there if you want. In that I just talk about basic finance things, and it's basically focused around the top 10% population of India and how they can climb up to 5% and top 1% in their respective countries, regions. Okay, it's irrespective of the country or region you live in. Basically highlights uh, the framework and the mental process behind how you can climb up the ladder, but all the tools at your disposal at different levels. Okay, so if you're interested in finance, you can check that out. Okay, so this is all for this video. Hope you got to learn something about this, something from this tutorial. See you all in the next video. Thank you, and don't forget to subscribe and like and share. Okay, bye.